Hello students, myself Kunjan Agarwal, Assistant Professor in Department of Computer Application in ABES Engineering College. Today, my topic is AVL tree in data structure. The topics that I am going to discuss are concept in AVL tree, examples of AVL tree rotation, type of rotation in AVL tree. Now let's discuss what is AVL tree. AVL tree was introduced in the year 1962 by three scientists, that is Adelson, Belsicki, and Landis. On the name of these three scientists, the name was given to a tree, that is AVL tree. AVL is a height balanced binary search tree. AVL tree is also said to be the binary search tree, but the binary search tree should be balanced. What is the property of binary search tree? That every left node should have a lesser value than the root, while the right node should always have a greater value than the root. But if the binary search tree is a balanced tree, then it is said to be as an AVL tree. Balanced in an AVL tree is being determined by the balance factor. So in an AVL tree, every node maintains an extra information known as balance factor, which is used to maintain the height of the tree balanced. Every AVL tree is a binary search tree, but not necessary that every binary search tree is an AVL tree. If the binary search tree is a balanced, then it is an AVL tree. In an AVL tree, balance factor of every node is either 1, 0, or -1. The balance factor of the node is calculated by height of the left subtree minus height of the right subtree, or height of the right subtree minus height of the left subtree. That is what is the formula for balance, determining the balance factor of each node. That is, balance factor is equal to height of the left subtree minus height of the right subtree. Let's discuss this, how the balance factor is calculated by an example being given on your screen. And that is what is this. It is an AVL. Let's check whether it is an AVL tree or not. See, a tree is being given, but it is a BST. How it is BST? See, at the top, we have the root node, that is 25. By the left node has a lesser value, and the right node has a greater value than the root, that is 36. Here again, let's see the 20. 20 is if the root, then 10 is the left node, which is a lesser value, while the 22, that is the right node, that is the greater value. So this tree is said to be the BST. But let's check whether it is binary AVL tree or not. Yes, it is an AVL tree because we have calculated the balance factor earlier. The balance factor of the top node is 0. The balance factor of the left node is 1, -1, 0, 0, 0. How we have calculated this balance factor? Let's see. Now, the formula for the balance factor is what? That I have just tell you, the height of the left subtree minus height of the right subtree. Now let's see for this node. Height is what? 0, 1, 2, 3. That is 3. Height of the right is 0, 1, 2, 3. That is again 3. That is 3 minus 3. That is equal to 0. So it is, balance factor is 0. Correct. Here let's see. Balance factor is 0, 1, 2. That is 2. 0, 1. 2 minus 1, that is 1. This is what? 0 minus, this is 0 and 1. 0 minus 1, that is equal to -1. Here it is 0. It is 0. It is 0, 1. And so we have calculated the balance factor of each node and we are finding it. The balance factor is either -1, 0, and 1. If we have three type balance factors of every node, that is 1, 0, and 1, then it is satisfying the property of AVL tree. And so the tree is said to be as an AVL tree, or you can call it as tree is said to be the height balanced tree. But this cannot be always possible. When we are inserting any node into a tree, like let's do an example. Let's see. If I have a node 31, here I have a node 28, and here I have a node 27. Okay, 32. I have node 32. Again, I'm inserting a node 33. Now let's calculate the balance factor. 0 and 1. Height is this 0, 1, 2. That is 1 minus 2. That is 1. Okay, let's again insert an element that is 34. Now let's see. 0, 1. But 0, 1, 2, 3. That is 1 minus 3. That is minus 2. The balance factor is, here its balance factor is 0. Here this is, let's see, 0. 0 minus 2. That is again minus 2. This is 0 minus 1. That is minus 1. Here it is 0. Here we are saying the balance factor is 0, balance factor is minus 2, balance factor is minus 2, balance factor is minus 1, balance factor is minus 1, 0. When we are saying that we have the balance factor minus 2 or plus 2 in a tree, that means tree is not balanced and tree need to be balanced. In order to make a tree balanced, we need an operation that is something said to be as the rotation. The rotation is a process of moving the nodes either to the left or right to make the tree balanced. So in order to make a tree balanced, what we have to do? We have to perform the process of rotation. When we are seeing the type of rotations, rotations are of two types, single rotation and double rotation. Single rotation is again can be done by two ways, left rotation and the right rotation. While double rotation is done by again two ways, that is left-right rotation and right-left rotation. Let's see one by one each and every rotation. Number first, let's see the left rotation. That is a single rotation, left rotation. In the left rotation, every node moves one position to the left from the current position. To understand left rotation, let's consider the following insertion operation in an AVL tree. And that is what is? See what we are doing here. We are inserting one by one node. Number first, we have what we have done. We have taken 1, inserted. 2 is greater than it. We will insert into the right. 3 is again we are inserting to the right. When we are inserting each and every node to its right, we are saying that its balance factor is minus 2. In order to make it balanced, what we are doing? We are doing the left rotation. What we are doing to make, we are moving the left. In order to make the left rotation, we are moving the node one position to the left. See, we are moving to the one position left, we are moving to the one position left, we are moving to the one position left. When we are moving to the one positions left, we are saying that the balance factor is now 0. Now 2 will become the root, 1 will be its left child, and 3 will be its right child. This is what is the left rotation. And because the balance factor is 0, and it is fulfilling the property of AVL tree. So this is what is something said to be the left rotation. Now let's see what is right rotation. Here again, what we are seeing, we are directly see into the diagram. Here we are going to move the every node to its right. Well, not to its left. In the left, we move to the left, but in right, we move to the right. Now here, what is seeing? We are having the node 3. We are inserting node 2. We are again inserting node 1 to the left because it has a lesser value. But it is, the tree is imbalanced because the balance factor is 2. Whenever I just told you, whenever the balance factor is minus 2 or 2, we have to balance it by making a rotation. Here we are going to make a right rotation. We will shift 3 to the right, 2 to the right, 1 to the right. And that will give you a tree. That is what is. 2 will be its root, 3 will be its right child, while 1 will be its left child. And so what we have done the right rotation. This is what is the single rotations what we have done. That is, in single rotation, what we do, we either move to the left, we move the node to the left or to the right, depending upon the balance factor. Depending upon the balance factor, where the tree is moving, whether the tree is imbalancing on the left or the tree is imbalancing to the right. But sometimes we also need double rotation, that is left-right rotation or right-left rotation. So let's now first discuss one double rotation, that is left-right rotation. In the left-right rotation is always a sequence of single left rotation followed by a single right rotation. Left-right rotation is what? Single left and followed by a single right. In LR rotation, at every node moves to one position to the left and one position to the right from its current position. So let's see with an example what we are doing. see in the diagram what it is. Here, can you see in this diagram? Here we have what? We have the node 3. Here we have inserted a node 1 to its left while 2 on its right. But it is what the balance factor is 2 on the root. And when the balance factor is 2 at the root, that is 3 is imbalanced. And we need it to be rotation. But this type of rotation is something said to be the double rotation. Here, first what we have to do, we have to first perform the left rotation and then we have to right. So in order to perform the left rotation, what we are going to do, we'll start from the downward part of it. First, what we will do, we will make 1 to the left and 2 again to the left. So make it a rotation as left rotation. So here what we are saying, one we have rotated to the left, 2 again we have rotated to the left, and we are seeing a tree in this position, that is 3, 2, 1. Now what we are going to do, we are going to rotate every node to the right. See, 3 we have rotated to the right, 2 we have rotated to the right, 1 we have rotated to the right, and then we will have a tree in this form, that is 1, 2, 3, that is 3 on its right, 1 on its left, and 2 is its root. And now the balance factor is 0. So this, when the rotation gives you balance factor 0, 1 or minus 1, then the tree is said to be a balanced tree, or you can call it as an AVL tree. But here we have performed 2 types of rotations. Number 1, the left rotation, and number 2, the right rotation. So this type of rotation is something the double rotation. Another type of double rotation is also there, and that double rotation is something said to be as right-left rotation. It is very similar to the left-right rotations, but in the earlier we have done first left and then right. Here, what we are going to do, we are going to first perform the single right rotation, and then it will be followed by single left rotation. Then let's see in an example in this image. Let's see what we are doing. Here, again, we have at the root what you are showing. You have 1, you have 3, and you have 2. But here, what you are showing, you are seeing that it is minus 2. Minus 2 means that the balance factor is minus 2. If the balance factor is minus 2, that is tree is imbalanced. You have to perform rotation. But in this, what you have to perform, first you have to perform the right rotations on the lowermost nodes. That is, on the 2, you will perform right. On the 3, you are going to perform the right rotation. When you are going to perform the right rotations, the tree will come in this form, that is 1, 2, 3, that is whole tree is being imbalancing at the right part. When it is being done at the right part, we are going to perform the left rotations on every node, that is on 1, 2, and 3. When we are going to perform the rotations on it, our tree will be something in this form, that is 2, 1, 3. That is 2 will be its root, 1 will be its left child, and 3 will be its right child. And so when we are going to calculate the balance factor, we will find that balance factor is 0. And when we are finding the balance factor as 0, we are seeing that the tree is balanced. So through the rotation process, what we have seen, when we are inserting any node, and if the tree becomes imbalanced, either on left or on right side, we can make it balanced by doing the process of rotation. So students, this is something about the rotation for today. It's about the AVL tree. What I've shown you, how the AVL tree can be said to be the balanced tree. Thank you so much. Today's for all. Happy learning. Thank you, students.